Hey guys, I hope that I'm live right now. If you guys are able to listen to me properly as well as there's no issues with the audio or the video, please do let me know. Hello everyone, I hope that I'm live right now. If you guys are able to listen to me properly as well as there's no issues with the audio or the video, please do let me know. Did you guys receive the update of today's class on your WhatsApp groups? Please let me know guys. You guys get the update for today's class on your WhatsApp groups? Please do let me know. Okay, great, great. Because I thought that very few people have started, have come up to the boot camp up till now. So I thought that has the update been sent or not? I think so. The updates are currently in the process of being sent. So I think so. It will take us 5 minutes. Everyone is able to join us with our today's class. No issues in that. Okay. Okay. So in the previous class, we had seen that we were working off with bar charts and the topic of understanding how to rearrange the bars in the order of their precedence, the number of counts is something that we'll be looking at today. So some additional variations and all those kind of stuff. And once we have done that, then we'll be proceeding further with like pie charts, then like ring charts, histograms. We'll also be looking at some other charts as well. This is everything that we'll be covering. So pie charts, bar charts, histograms, ring charts. So we'll be finishing off with our visualization process right over here. Okay. Okay. So this is what we'll be doing today, guys. We'll be looking at some of the charts and we'll be looking at how to write the code for the same, and we'll be trying to understand the concept for that as well. This is all that we'll be doing today. Okay. Okay. So good evening, everyone. Good evening. We'll try our best to keep the session short. Okay, don't worry about it. But we'll also try to finish up everything. Okay, that will be our primary goal. I don't know how much time it will take, but we'll try our best so that we are able to finish off everything as soon as possible. Okay. Is my voice a problem with everybody, or like, am I audible to everybody, or is that just a problem with Neural? Okay, so Amir has already like written what we have studied in the last project. So we have studied tidy, non-tidy levels of measurement, nominal data, ordinal data, interval ratio data, discrete and continuous data. So that's great that you are able to remember that. We also had like a question that I given to you about the same. Saqib Ahmed, I had put up a message on all the WhatsApp groups that yesterday we were facing some internet issues. My first class also was cancelled due to that because like the internet was not working, and that is the reason why like we had to cancel the class yesterday. Okay, okay, audible. Okay, so everybody is able to listen to me properly. That's amazing, guys. That's amazing. So we'll have one small video of like 5 minutes that will be posted by tomorrow morning on this channel where I'll be telling you guys the project that you have to make. Okay, so it will be very easy right over there as well. Okay, so we'll have a video of like 5 minutes. I will tell you guys how to submit the project, where to submit the project, how to make the project, everything right over there. Okay, so the project I will be working upon will be this project itself, that is the Pokemon dataset, and we'll look into how to create various different like graphs using the same dataset. That will be the project I will be having in this particular boot camp. And yeah, how to submit the project, where to submit the project, the process for the same, I'll be letting you guys know in a small video of 5 minutes that I will be uploading by tomorrow morning. So that will be the entire thing. Okay, We stopped at organizing the charts in descending order. We will be doing that as well. Don't worry about it. So I had given you a small assignment, that is interval and ratio data difference and understanding the examples for the same as well. So can somebody let me know what is the difference between interval and ratio data? Okay, can somebody let me know what is the difference between interval and ratio data? Prakhar Goyal, the code is working absolutely fine. There's no issues in that. Okay, the deadline for the project, how to submit the project, where to submit the project, I will be letting you guys know. I will be uploading a video of 5 minutes long by tomorrow morning on this channel itself, and you'll be I will be letting you know all that in that video. So don't worry about it. Okay. Yeah, I've given you a particular question, that is the interval and ratio data assignment. So can you guys know, okay, can you guys let me know what is the difference between the two? Rohit, zero differences, that's absolutely wrong. Okay. IQ, temperature, interval data are examples of interval data, IQ and temperature. Okay, but why why ratio, why interval, guys? Like I need to understand that you have understood it. Okay, again, Shetty, really copy pasting the example answer from Google won't work. I need you guys to understand the difference between the two. Ratio can have a natural zero. So an example of interval data is temperature. Can temperature not be zero? Okay, so Amir is writing a good answer that difference is ratio can be negative and meaningful at zero. Okay. But what do you mean by that? What do you mean by the statement that ratio can have a natural zero but not interval? What do you mean by that, guys? Interval scales hold no true zero and can represent values below zero. For example, you can measure temperature below 0 Celsius, that is minus 10 degrees Celsius. That's correct, Ramesh, that's correct. While interval and ratio data can both be categorized, rank and have equal spacing between adjacent values, only ratio scales have true zero. For example, temperature in Fahrenheit or Celsius is. Again, like guys, you are writing true zeros exist, true zeros don't exist. And what is the meaning behind that? That was the assignment, to be able to understand. Like, if there is a particular person, if I'm trying to explain it to you, like, how would you explain what is the difference between like interval data and ratio data to a layman, like who has not understood anything? How will you be able to understand that to him? Okay, I need to understand that you are able to understand the core concepts behind that, guys. A ratio variable has all the properties of interval variable, but also a clear definition of zero. Okay. Okay, so most of you have understood the differences between the interval and the ratio data, but whatever answers that you're giving me is very technical in nature. It's great that you are able to remember the technical answers as well. That's also something that you need to do at any point of time. But like if somebody would be then questioning you a lot, you won't, and if you're not able to understand that particular concept, like the crux of the concept, why is temperature and interval data not a ratio data? Why is like land as an area a ratio data and not not an interval data? Why is that the case, guys? That is something that you need to understand. Okay, so give it some time. Okay, try to figure it out, try to go in a little bit more depth into it, because this is a question that is very famous when it comes to data science interviews. Like this is a question that will be asked to you guys, and then there's a pain point, like because it had been asked to me and I was not very clear with the concepts. I remembered the entire definitions, I remembered the entire examples, but like that person continuously pestered me upon understanding the concepts, and I was not able to do that at that point of time. That is why I'm telling you guys, interval and ratio data is a very important concept, guys, and please try to get some like time, devote some time to understand the crux of the concept as well. Okay, shall we start off with our today's class, guys? Please let me know. Should we start off with our today's class? Please let me know, guys. Should we start off with our today's class, guys? Please do let me know. Okay, great. Okay, now again, going back to our collab notebook. We are going back to collab. Inside collab, we have to go to file. From file, we have to go to open notebook. Again, in today's video, if you're going to the description of today's video itself, you'll be able to find the links to 2 of the notebooks. Okay, you'll be able to find the links to 2 of the notebooks, guys. If you scroll down below, you will be able to find note 1 and note 2. First of all, we need to open up note 1. Inside of note 1, we are having the link. We have to copy out the link. This is what we are going to use right now. And then we'll be pasting it out on the Google Colab. So selecting GitHub, pasting it out on Google Colab. So this is something that we have already done, not reiterating over it. Let me just open up the live chat in a second. Okay, up to that point of time, I'm just connecting it to the servers. Okay, so I've opened up the live chat as well. Okay, great. Okay, so let's get started with our today's class, guys. Okay. Okay. Again, I'm just explaining to you guys today we'll be covering out all the things that are essential for our data visualization process. That is the bar graphs, histograms, pie charts, ring charts. And after that, the project that you will be submitting will be the Python, like whatever like we are doing right now, you will be submitting the exact same thing. But which project to submit, how should the project look like, where to submit the project, how much time will be given to you to submit the project, all that will be, I will be letting you guys know in a 5-minute video that I will be uploading by tomorrow morning. So please be ready for that. Okay, today we'll be covering out all the concepts that are needed for the same, and then we'll start off with the same. Okay, so let's get started, guys. So we were right over there we had stopped here. So what we want to do is we had created our entire plot. As you're able to see, we had created our entire plot right over here. Now, as you're able to see, for example, for generation 1, it's approximately 145. For generation 2, it's approximately around 100. For generation 3, it's approximately 140, and so on and so forth. But what if I want to get the order in which they have been created? Like the maximum one first and the minimum one at the list. I want to see the order of the bars as well. For that, we are having separate code in which we just have to specify the order in which we want it to be indexed for us. Right over here, while creating the order for the same, okay, we are using gen order. Okay, that is, we're creating a variable called as gen order, that is the order between the generations. Right over there, we are using Pokemon.generation ID. That basically gives us 1, 3, 4, 5, and all these kind of numbers right over here. Okay, so whatever the numbers are inside of generation ID column. So this is basically getting us the generation ID column. If you remember correctly, generation ID is a column right over here to be able to access. Now this is a matrix. Okay, this is a matrix. Now if I want to get access to this generation ID column from right over here, I have to specify it inside the parentheses. I have to specify it inside the parentheses, just like we used to do for your, if you remember it correctly, your dictionaries. Okay, think about it as your dictionaries. So this is the column name that you have to specify. Then you are able to get all the rows of that particular column, all the rows of that particular column. So it will basically return to you this entire column of this 1 to 7 numbers. Okay, once you've got that, I want to apply another rule of NumPy called as value counts. Okay, I want to apply another rule called as value counts. This will basically count all the values for each of those generation IDs, number of occurrences of each of those generation IDs. For example, we know that there are 5, 1, 3, 4, 2, 7, 6. These are the generation IDs that we are having. So value counts is a particular method that can be applied over that particular column to be able to give us the exact values, exact number of counts of these values. So let us look at this. Okay, so we will have to run the entire code again. Give me a second. So right over here, if I'm running this particular code, let us take this into a separate line. So let us take it like line by line. Let us take it by line so that you are able to understand. The first one that we are having is Pokemon generation ID. Okay, let's check what we are able to get from Pokemon generation ID. Okay, so we are able to get, okay, so I have to upload the dataset as well once again. Let me just upload the dataset. Pokemon.csv, that is something that we'll have to upload once again because we have disconnected. So every time we are disconnecting from the runtime, we will have to update it again and again. Okay. I think so now it should be working. Yeah, everything is working right now. So if you are writing Pokemon generation ID right over here, we are able to get that. Okay. So we are able to get the entire column. As you are able to see, this is the generation ID column. This is the generation ID column. Now if I'm writing dot value underscore counts, okay, value counts counts right over here, let's see what happens. We're able to get that. Okay, generation ID 5 exists 156 times, generation ID 1 exists 151 times, generation ID 3 exists 135 times, generation ID 4 exists 107 times, generation ID 2 100 times, 7 86 times, and 6 72 times. So it has listed out the entire generation IDs according to the number of counts, which 5 at the maximum and 6 at the lowest. Okay, so it has also given us the intrinsic numbering system as well. Now we want to apply. So this order, this is again a new attribute inside our count subplot. We have looked at data, we have looked at X, we have looked at color as well. Now we are using order. Okay, now order needs to take in this index. It needs to get this index. So this value counts has already taken up all our generation IDs and given us the maximum occurrences, that is 5, and the lowest number of occurrences as 6. I want to pass on this entire index right over here. I want to get this index right over here. So for that is like 5 1 3 4 2 7 6. This is what I want to pass. So I want to get the index from this dot value counts dot index. Value counts dot index. So that is basically giving me the exact occurrences, the index itself as a NP array. It is able to give me an index itself as the NP array, with 5 having the maximum occurrences and 6 having the lowest occurrences. And this is what I'm passing in gen order. As you're able to see, I'm just passing this entire thing inside a variable called a gen order, and then I'm putting the order as gen order right over here. So I'm saving this and I'm running the code right over here. I'm able to get the entire plot with 5 like listed at the top, and then 1, then 3, then 4, then 2, then 7, and 6. And this is according to the order that we have given. Are you guys able to understand this? Please let me know, guys. Are you guys able to understand this? Please let me know, guys. Are you guys able to understand this? Please let me know. Are you guys able to understand this particular piece of code? Please let me know. So D type int 64 is another data type of NumPy, because NumPy is a scientific computing library. So for them, like, they have some additional data types as well. We don't want to care ourselves with that right now. We just want to use it as a normal array itself. So it's a normal NP array. Okay. Again, I will just explain it to you guys. So I want to order it according to the number of occurrences. Now Pokemon generation ID is basically giving me the entire column of generation ID. Now if I'm using dot value counts on this, it will count the occurrences of each of those generation IDs. So 5 exists this many number of times, 1 exists this many number of times, and so on and so forth. And it also arranges it in the maximum to minimum order. It arranges it into the maximum to minimum order. Now I want to get this order itself. I want to get this index. I want to get this order. So for that, I'm using dot index. It basically gives me the index of this table that has been created. It gives me the index of this table that has been created. As we are able to see from right over here, we are getting the index in the format of an NP array. We are getting the index in the format of an NP array. And this NP array, that is your NumPy array, we are passing out as the order. as an argument order right over here in our count subplot, and we are running this, it is rearranging all the tabs, all the bars according to the order itself, according to the generation order itself. Are you guys able to understand this? Please let me know, guys. Great. Amazing, guys. Amazing. Now let us look at some additional variations that we need to understand it. Okay, if you have a lot of categorical levels or category names that are long and that you might end up overcrowding of the tick labels. Now these labels that you are able to see down below, 5, 1, 3, 4, 2, 7, 8, 6 are called as tick labels itself. Okay, X ticks and Y ticks. Okay, that is basically the labels that you are able to see. That is defined as X ticks and Y ticks. Okay, so X axis, the ticks are there called as X ticks. On the Y axis, they are called as the Y ticks right over there. Okay, so right over here, if I'm plotting the data as Pokemon, okay, I'm plotting up the type 1 column. Okay, I'm having the type 1 column. If you remember this, guys, okay, type 1 right over here. Okay, I'm plotting it out, and I'm putting up the color as green. So I'm taking up this sb.color palette too. So this is also something that we have already discussed. So I'm running this particular line of code, as you're able to see, as the words, as the ticks from the type 1, that is grass, and then fire, water, as these are so many that they are overlapping with each other. They are overlapping with each other. I'm not able to read it properly. I'm not able to read the X text properly right over here. So for that, there are two ways in which we can deal with this. One of the ways to deal with this is that you can use the Matplotlib's xticks functions and its rotation parameter to change the orientation in which the labels have been depicted. Okay, so let's try to understand what I've told right over here. So instead of putting it up horizontally, instead of putting up the ticks horizontally where they are overlapping with each other, we can put it up as vertical ticks as well. We can put it up as vertical ticks. To be able to do that, what you have to do is, once you have created the sb.soundplot, normally you have to use the plt, that is the matplotlib.pyplot. If you remember it correctly, plt is the short form that we have imported for matplotlib.pyplot as plt. Now this provides you some additional tools so that you are able to change the layout of the plots that you are creating. Okay, so right over here we are doing matplotlib.pyplot, that is your plt itself. Okay, plt.xticks, that is the ticks that are present on the x-axis. Again, xticks basically means the ticks that are present on the x-axis, the labels that are present on the x-axis, and we are changing the rotation to 90 degrees. We're changing the rotation to 90 degrees right over here. So what we are basically doing is, it was horizontal first of all, the xticks. We are rotating it to be vertical in nature. We're rotating it by 90 degrees to be vertical in nature. In this particular format, nothing is overlapping with itself. Okay, nothing is overlapping with itself. Now this is one of the ways in which you can handle it. The second particular way in which you can handle it, so instead of changing the rotation of the xticks, what you can do is, instead of plotting the entire thing on the x-axis, we can plot it on the y-axis. Okay, instead of plotting it on the x-axis, the type 1, we can plot it directly on the y-axis. So I'm running this particular line of code, as you're able to see. Instead of plotting it on the x-axis, we are just plotting it on the y-axis. I'm running this particular line of code, you are able to see that right now as well, nothing is overlapping with each other, and it's easy to read as well. Okay, that is the beauty of like visualizations. You have to understand which particular visualization is much more suited for your use. So for example, right over here, I'm able to see all the plots properly, as well as I'm able to read them properly as well. Over here, I was not able to read them, like grass, fire. I had to tilt my head to be able to read them properly. Right over here, we can directly read it. Okay, and we have not done anything else, anything fancy. We're just plotting it on the y-axis side over here. Okay, Rupak, one of my suggestions to you guys would be, whenever you have a question like, can we use minus 90 degree? You have the notebook, just open the notebook and do it yourself. So you are able to understand, you will be able to test out various different things right over there. Okay. Okay, so this is how you will be able to plot it on the y-axis, and everything is working fine. You don't have to do any kind of rotation right over there. Okay, are you guys able to understand this? Please let me know, guys. Are you guys able to understand this? Please let me know. Great, guys. Amazing, amazing. Next, we are having counting the missing data. So for example, in the entire plot, okay, in the entire data set that has been given to you, there may be many a times where your data set is having some missing data. It is a non-tidy data set itself. Yeah, there's a missing data present in the data set. Now, how to handle these type of missing data? So one of the interesting things we can apply bar charts is through the visualization of missing data. We can use the pandas functions to create a table with the number of missing values in each column. Right over here, as you're able to see, to choose, like, so for example, we are having the Pokemon dataset. Okay, we are having the Pokemon dataset right over here. The Pokemon dataset looks like this. Now I want to check for each of these occurrences, for each of these elements that are present, each of the data that is present right over here. I want to check whether it is like empty or not. Okay, whether it is NA in Python, we call it as NA, or is this empty or not. I want to check that. Okay, that for, is this Bulbasaur, is this a value, or is there no value right over there? Okay, is this a value, or is there is no value right over there? Okay, so right, what we are going to do is we're going to write Pokemon dot is NA. Okay, we are going to use Pokemon dot is NA right over here. So that will basically check for each of these data whether it is like empty or not. It will check that for us. So if I'm running this particular line of code, as you're able to see, we're getting like, okay, so this is false, this is false, this is false. As you're able to see, there are some true values as well. There are some true values as well, that this is empty. This is also empty right over here. This is also empty right over here. And rest, where there was data already present, we are getting false. That is, it is not empty. Okay, so now we want to count the occurrences of these like true values. Now true is basically 1. The intrinsic value of true is 1, and the intrinsic value of false is 0. Okay, the intrinsic value of true is 1 and the intrinsic value of false is 0. So if I want to calculate in each of these columns how many empty values are there, how many NA values are there, how many places are there where there is no data that has been given to you. So what you can do is you can just calculate the sum of all the rows. Okay, for each of these columns, you can just calculate the sum of all the rows, because false is 0, true is 1. True means that there is an NA value, that there's no value right over there. Okay, so if you're just calculating the sum of all these false values and true values for each of these columns, you will be able to get the number of NA values or the number of empty values right over there. Are you able to understand this? Please let me know. Are you able to understand this concept? Because false has value 0, true has value 1. So if I'm calculating the sum of all the columns individually, so I'll be able to get the number of NA or the number of places where there is no data for each of these columns. Are you able to understand this? Please let me know, guys. Great. So for that, I just have to use the dot sum property. I just have to use the dot sum property right over there. So we will calculate the sum of all the values present in each of these columns. It will calculate the sum of all the values present in each of these columns. So if I'm running this particular line of code, okay, if I'm running this particular line of code, you are able to see that for type 2, we are getting 402 occurrences of NA, and for the rest of the columns, there is no occurrence of any kind of NA right over there. Okay, for type 2, we are getting 402 occurrences of NA, but for the rest, there is no occurrences of NA right over there. Okay, we can even visualize this. Okay, we can even visualize this as well. So Pokemon dot is NA dot sum, we are able to save it into a variable right over here. Okay, and then we are setting up the base color palette as well. And now we are putting up a bar plot. Okay, we're putting up, now you can, so count plot basically works upon the columns that are there. Okay, count plot basically works upon the columns that are there. Right now we want a custom plot. Okay, we want a custom plot that is outside the data set. Okay, we want to create a custom plot that is outside the data set. We want to plot this. We want to plot this particular table. Okay, this is the table that we want to plot. We are not plotting it from the data set. We are not plotting it from the like Pokemon data set. We are plotting it out of this particular table itself. So the labels, okay, the labels is this indexes. The labels is the index of this table. Like, as you're able to understand, the labels, the X text will be the index of this table, and the values that you want to plot is the value of this particular table itself. So this is the table that you want to use. So you cannot use count plot right over here. Count plot is for your data set. Now you are creating a custom plot. So for that, you are having the bar plot method. Okay, you are having the bar plot method. Right over here, you are having the NA counts. That is the table that we have created. Okay, that is the table that we have created right over here. So we are having the NA counts dot index dot values. That basically gives us the like values from the table itself, and then we are having the NA counts. Okay, that is the table itself. If I'm running this line of code, as you're able to see, we are getting the value as this. So let us look at what is this NA counts.index.values. Let us try to understand that as well. Try to understand and see what this is. So if I'm writing a new code right over here, let's first look at what is NA counts.index. Okay, so when I'm running NA count.index, we are getting the index, that is ID, species, generation ID, height, weight, base, experience, blah, 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 blah. You need to get the values as well. So dot values. Okay, dot values will basically give you the entire text. Okay, so dot index and dot values, you will say that, sir, both of them look the exact same. Okay, but this is not an array. This is not an array. This is just the index right over here. We cannot use that. So we need to use the values out of it. Okay, we need to use the values out of it. So it will convert it into an array for us. Okay, if you're directly writing index, as you're able to see, it is an index. It is just providing us a list of indexes itself. Okay, we cannot use this. We need to have an array. We need to have a proper ND array. For that, we use dot values. We use dot values to be able to get it and convert it into an ND array right over here. So we're able to pass this ND array, that this is the ND array. This is the like labels that you have to use. NA counts basically pass on the numbers that are there. Okay, that is the table that we have created. So this is the NA table that we have created right over here. And then we are having the color as the base color. Then we are taking up the base 0 color itself. When I'm running this line of code, we're able to get this particular thing. So we are having the indexes on the xtext, and we are having the plot, and we are able to see that only the type 2 has a lot of NA values inside of it. Are you guys able to understand this? Please let me know. Of course, you can like choose not be to use this and go with directly like Y plot itself, but that isn't something that I will be like suggesting you guys. Okay, by default, according to me, you should be taking up the rotation values for bar charts. Okay, for bar charts, take up the rotation values. Okay, what is NA? Cannot understand this part. Okay, no issues. Let us look at an example right over here. Are you able to see this type 2? Are you able to see this type 2? You're having poison, 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 and then NaN. That is, there is no data that has been provided to you. There's no data. This is an empty place. There's no data. According to Python, there's no data right over there. So that is what we are calculating. That is NA. That is NA. That is non-existing, like something like that. I don't know the full form for that. Okay, but it is referred to as NA. Okay, there is nothing right over there. No value right over there. Okay. Okay. So now that we have covered this, let us move on to our part 2. Okay. So again, you have to go to file. You have to go to open notebook. Okay. Right over there, you have to go back to the description of the video. You are having the notes 2 right over here. Just open up the notes 2 from there. Copy the URL. Yeah. Type 1 is one of the columns of the dataset. Okay. And then go to GitHub and then paste the link. Search for it. Not available. Okay, great. Not available. NA means not available. I'm not very sure if that's true or not, but like I think that should be the answer. Let's connect to the servers, and this is the second notebook that we are going to use to learn pie charts and histograms. Okay. Okay, again, we'll be importing all our NumPy, Pandas, Matplotlib.pyplot as PLT, Seaborn right over here. So let's import it. We'll also have to upload our Pokemon.csv file again. So let's upload the Pokemon.csv file. So once we have uploaded that, we can read the CSV file as well. And you will be able to see the CSV file right over here. So this is the exact same CSV that we were working upon right over there. Okay. So right now we need to understand about pie charts. See, most of these charts you have already studied in your school time itself. So there's not a lot that we need to discuss about that. A pie chart is a very common univariate plot type that is used to depict the relative frequencies for levels of a categorical variable. This is where you use ratio data. Okay, this is where you use ratio data. Frequencies in a pie chart are depicted as wedges drawn on a circle. The larger the area or the angle, the more common the categorical variable value is taken. Okay, so that is the exact same thing. Okay, so right over here we can represent this particular cat var is an example of a bar chart right over here, and you're able to represent the exact same thing as a pie chart as well. They're having delta, beta, gamma, alpha, and you're able to see from this pie chart which one is the highest, which one is the lowest, according to the angles that they have. Okay. A pie chart and a bar chart displaying the same categorical counts. Unfortunately, pie charts are fairly limited plot type in the range of scenarios where they can use. It is easy for charts makers to try and spice up pie charts in a way that makes it very difficult to read. So for example, okay, many a times what happens is you must have seen pie charts being represented in such a way. Okay, many a times when you are going over some news channel or something like that, you will see that pie charts are represented in such a way. Okay, it will show you something like this, and you will feel as if like this is the like this is the smallest area and this is the largest area and so on and so forth. But when you are putting it up on a like a two-dimensional plane, it will look something like this. So you will feel as if this is the largest and this is the smallest, and in reality it would be the exact opposite. It will look something like this, in which the one that is on the background is the largest and this one is the like second largest and this one is the smallest. So that is how like people are able to like manipulate graphs to be able to like change the perception of the people around the entire world. Okay, so that is how like you need to keep in mind, like you can use graphs for like manipulating the data as well, although the data says something else, but just manipulating the graph in such a way and showcasing it at such an angle that you believe the answer to be a lot different. Okay, so you need to keep that in mind, guys, that you are not doing something like that. Okay, so right over here, make sure that your interest is in relative frequencies. When should you use pie charts? That is what I'm trying to answer that. Okay, areas should represent parts of a whole rather than measurements on a second variable. Okay, for example, it's a pie. Okay, you are showing parts of a pie. It shouldn't be like you're taking up the example in which the entire thing is not making up a whole. Okay, so for example, the total number of Pokemons is like 700, and you are making up a pie chart of the power levels of each of these Pokemons. So yes, you are taking up the entire Pokemon data set in general and making up the pie chart over that. It shouldn't be like you're making up the pie chart of like Pokemons and just taking up the poison type Pokemons only right over there. This is not something that you want to do. You want to make sure that when you're using, so these are all something that you must have studied in your childhood as well. So pie charts is basically like you're showing parts of a whole. Okay, you need to make sure that all the parts add up to be one like entire data set itself. That is something that you need to remember. Okay, limit the number of slices plotted. You shouldn't have like 50 different slices in the same pie chart. That shouldn't be the case, because then every single wedge will be so thin that you won't be able to understand anything out of it. Okay, so it should be not more than 4, 5 or even 6, like not more than that number of categorical variables should be there. Because if there are a lot many number of categorical variables, that means that it will just make every single wedge so thin that you will not be able to understand anything. Okay, plot the data symmetrically. So never, like a common rule of thought process while plotting a data set is that you should never plot a data set like this. You should never plot a data set in such a way. If this is something that you want to do, if this is a particular plot that you want to do, it should look like this. You want to start the line from the entire middle and then go around in clockwise direction. This is how your entire plot should look like. Like it should start from like 12 noon. It should start from 12 noon and then that should be the plot. This shouldn't be the case. Okay, this shouldn't be the case. Are you guys able to understand this? Please let me know. Are you guys able to understand this? Please let me know, guys. You should be plotting it starting from the midnight, like 12 noon itself, and then going out in the circular direction, not like this. It shouldn't be abrupt like this. This shouldn't be the case. Okay, so let's look at the pie charts as well. Okay, so again we are using value count, so basically count the number of generation IDs that are there. Okay, and we are using the PLT, that is your Matplotlib PLT.py. That is how you are able to plot a pie chart. sorted counts, that is the df generation id dot value counts. The labels that you want to create is sorted counts dot index, that will give you the labels out of the sorted counts. You want to start the angle as 90 degrees, so that is, you want to start it at the middle. So for that, you are having the attribute at start angle is equals to 90 degrees. That is, you are starting at the very middle of the entire pie chart, and counterclockwise as false, that you want to go in the clockwise direction itself. Okay, you want to go in the clockwise direction. You want to plot it in the clockwise direction itself. So I'm running this little line of code right over here. As you're able to see, you are having 5. Okay, then 1, then 3, then 4, then 2, then 7, and then 6. If you remember it correctly, what is the value that this gives us? Can somebody let me know? This particular line of code, what is the value that it will give us, guys? Can somebody let me know? Sorted counts. What is sorted counts? Can somebody let me know? We have discussed about it. That is the reason why I'm asking you guys, just to make sure that if you are listening to me properly, what will be the answer that we'll be getting from df generation ids dot value counts? Can somebody let me know? Can somebody let me know, guys? Okay, so number of each occurrences of each of the types, as well as it is in the descending order. Okay, it is in the descending order. Okay, so that is number of counts in descending order. Okay, and then what will this give me? Sorted counts dot index. What will this give me, guys? Can somebody let me know? What will this give me? Sorted counts dot index. What will this give me, guys? Sorted counts dot index, guys. What will this give me? Can somebody let me know? Sorted count dot index. What will this give me, guys? All the indexes name, and here the indexes are the generation IDs, that is 1, 2, 3, 4, 5, 6, and 7. Okay, so it will give me the index name right over there. Start angle is basically starting from the middle, like I said, and counterclockwise is equals to false, is that you want to go in the clockwise direction itself. To go into the clockwise direction itself. plt.axis square, if you're not putting this up, if I'm removing this and running the code right over here, okay, so it might appear to be in an oval shape as well. To make sure that is not happening, okay, for some data set, it might occur in an oval shape. To make sure that is not happening, we want our entire plot to look as a proper circle. That is why we are getting the plt.axis as square. That makes sure that the length and the width is the exact same, and we are getting a circle right over here. You're able to see there is some difference here as well. I'm rerunning this. You're able to see like, oh, there's some difference, like a very subtle difference right over there. That is the reason why we are putting up your plt.axis square, to make sure that the axes are square in nature, and you're always getting a circular pie at the end of the day. You're getting the circular pie as well. Okay, are you able to understand this? Please let me know, guys. Guys, able to understand this? How to plot a pie chart? Please let me know. Guys, able to understand this? Please let me know, guys. Amazing, 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 guys. Okay, so a sister plot to pie chart is called as the donut plot. Okay, it's just like in pie chart, except that there is a, like donuts, you must have eaten donuts, like Krispy Kreme is also great, or like maybe donut center or something like that, wherever you like to go and eat, mad over donuts or anywhere else as well. So I hope that most of you are familiar with donuts. You can even create a donut inside of pie charts as well. You can even create the donut inside of pie charts. So right over here, as you're able to see, I've created this donut chart. The code for the same is exactly the same as pie chart. Okay, the code for the same is exactly the same as pie chart. That is that you are just having one more attribute at the end. Wedge props is equals to width is 0.4. Wedge props is equals to width is equals to 0.4. That is basically giving me the width of this, the radius of this particular circle that I want to cut out. Okay, if what happens is right over here, if I'm decreasing this to 1, okay, if I'm decreasing this to 0.1, as you're able to see the wedge, okay, the width of the donut is basically 0.1 of the radius. Okay, it's 1/10 of the radius. Okay, similarly, if I'm increasing this to, let's say, 0.5 right over here. Okay, so this is with the width is almost 50% of the radius. The width of your plot will be 50% of the radius itself of the pie chart. If I'm increasing this to 1, you will get the exact pie chart itself. You'll get the exact pie chart itself. So that is how you can create a donut plot. Okay, you can create a donut plot. Okay, so it is as simple as writing wedge props is equals to width. This is a dictionary, as you're able to see. We have already studied about dictionaries. So the width we are specifying at 0.3 right over here. Then convert a pie chart to a donut plot as well. Okay, are you guys able to understand this? Please let me know. Are you guys able to understand this code? Please let me know, guys. What happens if it is more than the radius? Let's check that as well. So 1.6. Okay, as you're able to see, if I'm putting it up as 1.6 right over here, we are getting like the left hand side getting imposed over the right hand side. We don't want that. This is not something that is usable for us. That is the reason why we don't do this. Okay, so we usually keep it at 0.3 or 0.4 to be able to get a donut plot itself. Okay. Next is histograms. The histograms is also something that you have already studied about in your mathematics. So not a lot to cover right over there. We will just look at the code. Okay. A histogram is used to plot the distribution of a numeric variable. Is the qualitative version of the bar chart. Okay. So rather than bar charts were basically used for showing the like how many occurrences of each of the categorical variables are there right over there. Okay. But right over here, we want to like look at some continuous data. Okay, so most of you are very familiar with the differences between histograms and bar charts. Are you guys familiar with the differences between histograms and bar charts, guys? This is a topic from like 6th or 7th standard. Okay, are you guys familiar with the differences between histogram and bar charts? Please let me know. And I hope that most of you are like in college or even like +10. So I don't think so discussing the difference between a histogram and a bar chart would be something that would be beneficial. Okay, so should we directly move on with the code itself, guys? Should we directly move on with the code? Please let me know, guys. Great. So if you want to plot up a histogram right over there, okay, you are having the plt.hist function. Okay, you are having the plt.hist function. My God, people have forgotten histograms as well. Okay, I will just go over it, okay, once. So you are having some data like categorical data where you are having, let's say, generation 1 is occurring like 100 times, generation 2 is occurring like 150 times, and so on and so forth. So that is basically plotted using the bar chart. Okay, where you are having the labels right over here and you are plotting up the occurrences of each of these labels. You are plotting up the occurrences of each of these labels. But what if your data set is like speed? Okay, your data set is like speed. Okay, so speed is not something that you will be having like a particular person going at 10, a particular person going at 15, or so on and so forth. Speed is basically that is continuous data. So it will be like 15, 14.9, 13, and so on and so forth. That is a continuous data right over here. To plot something like that, you are having a histogram where you are having the speed right over here. Okay, so 13, 14, 15, 16, so on and so forth. And the occurrences of each of these speed is basically given as a particular histogram. So for example, between 13 and 14, whatever values are present, like whether it be 13.5, 13.4, 13.1, 13, so that will be counted in this particular bar chart, and so on and so forth. So that is how a histogram basically functions. I hope that you are able to revise this. And like you need, see, if somebody tells you na ki like your current knowledge is not essential, like whatever you are studying in school, whatever you are studying in college won't be of any help to you in the future, they're just bullshitting you. Like anywhere like integration, differentiation comes up to like machine learning, deep learning, you have to know integration right over there. If you are learning about like data science, you'll have to know about like data variations, statistics that you have studied in your childhood. All that comes into play right over here. All the knowledge that you're gaining at any point of time, please try to make sure that you're at least able to remember something as basic as a histogram. Okay, right over here we are having the hist data set that we are going to use. The data that we are going to use is the df, that is our So df is basically your pandas.read csv, pokemon.csv. So that is our data set that we are having right over there. So we are having the data set as df, and the x-axis we are putting up as speed. That is the column that we are going to use. So I'm running this particular line of code. As you're able to see right over here, we're getting a histogram in which, for example, between 0 to 20, there are like 25 occurrences of Pokemon that are there. Between 20 to 40, there are 85 or 90 occurrences of Pokemon that are there. Between 40 to 60, Pokemon's having speed between 40 to 60, there are 160 occurrences of Pokemon like that, and so on and so forth. So this is how you are able to plot a histogram. Now in this histogram, how we are able to define that, okay, from where to where this plot has been made, okay, from where to where this particular boxes have been made. Okay, so for that you are able to see this array right over here. You are able to get this array right over here. So the first array that is occurring is between 5 and 20.5. The second occurrence is happening between 20.5 to 36. The third occurrence is happening between 36 to 51.5. As you can see, this is from 5 to 20, then 20 to 36, from 36 to 50.5, and so on and so forth. So this differences have been made internally by your hist. Okay, by your hist itself. Are you guys able to understand this? Please let me know. Are you guys able to understand this? Please let me know. And their values. Okay, so for example, between 5 to 20.5, 31 occurrences of Pokemon are there. Between 20.5 to 36, 93 occurrences of Pokemon are there. Between 36 to 51.5, 163 occurrences of Pokemon are there. So you are able to show this in an array format, as well as you are able to plot it out as well. If you don't want to see this, if you just want to look at the plot, you can put up a semicolon at the end. Okay, you can just put up a semicolon at the end. So it will not print out that data for you. It will just show you the entire plot. It won't print that data for you. It will just print out that particular graph itself. Okay, so for that you just have to put up a semicolon at the end. Okay. Okay. So right over here, for example, if you don't want to so right over here, this is called a bins. Okay, this particular each of these bins that were created right over here, 5 to 20.5, 25, 20 to 5, 36 to 51.5, and so on and so forth. Each of these range is basically called as one bin. Right over here, how many bins are there? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So by default, we are getting 10 bumps right over here, 10 bins right over here. But what if you want to decide how many number of bins, how many number of towers you want to get? Okay, for that, you just have to specify bins is equals to 20. So it will divide the entire data set into 20 pieces. Now how it is able to do that? Now the Pokemon with the minimum speed is 5. The Pokemon with the maximum speed is 160. So it will divide the entire range into 20 parts. Okay, it will divide the entire range into 20 equal parts between 5 and 160 right over there. Okay. So as you're able to see, we are putting up the bins as 20, and if I'm running this little line of code, we're able to get 20 bins, and this is the distribution that we are able to see. The distribution that we are able to see. You can put this up as like 60 bins as well. That is totally up to you. It will put up the entire thing like this, so it will look something like this. But histograms are only beneficial if you are having like the bins to a lower number, okay, like 20 or 25. That should be the maximum that you are able to go to, so that you are able to see the entire data, see the pattern with the data as well. The guys able to understand this? Please let me know, guys. What is the use of that semicolon? Okay, so right over here, you don't want this data, you don't want this text to occur alongside with the ask Ashish to send me an email with the link. Okay. So right over here, as you're able to see, this is the plot that you're having. If you don't want this text, so you can just put up a semicolon at the end and run it again. So you will not get that text, you will only get the graph right over here. Okay, you will only get the graph right over here. Okay. You can use descriptive statistics to gauge over what is the minimum and the maximum bin limit that might be appropriate for the plot. These bin edges can be set up using the numpy's arrange function. Okay, so right over here, what is happening is that you want to have the Okay. So you don't know what is the minimum and the maximum value out of the speed of the Pokemon. Okay. You don't know what is the maximum and the minimum value of the speed. Right now, the bins are basically made as, okay, so you're having the data of the speed. You are having you're having the data of the speed right over there. Okay, so you're having the minimum value that is 5, the maximum value that is 160. So you're specifying, okay, I need 20 bins right over there. So it is taking up 20 bins from here and it's dividing the entire thing into 20 different parts. But what if I want to have like the bins and like I don't know how many number of bins will exist for me, but I want to have it like I want to have like 5 to 10. I want to have it in like occurrences of 5. I want to have the intervals in 5, then 10 to 15. I wanted to have like in the occurrences of 15 to 20 and so on and so forth. I want up till like 155 to 160. This is the bin that I want to have. This is the bin size that I want to have. Right over here, either you can just sit and calculate how many number of bins that will take me and then like put that number of bins right over there. Okay. Okay, so for that you have to use the np.arrange function. Okay, so np.arrange function is basically used to create an array. Okay, we have already seen np.arrange and then we used like 20 and it created an np array for us. If you remember in NumPy we have seen that. Okay, we used np.arrange and we put up in the brackets 20 and it created a array for us that had 20 right over there. Now what if I want to have like so when you use np.arrange, if you remember it correctly, do you guys remember np.arrange clearly? Please let me know. Do you remember np.arrange, guys? Df is the name of the so right over here, as you're able to see, df is nothing else but the variable name inside of which we have saved our Pokemon. Okay, the data set that we are having. So remember np.arrange right over there. So you were having np.arrange and then you were writing 20 right over here and it was generating an array for you starting off at 0 1 2 dot up till 19. Now what the another version of this np.arrange is, what if I want to start from a particular number? Okay, so for that I will be having np.arrange where you want to start, where you want to end, okay, and steps. Okay, at what step do you want to proceed? When you're just putting up 20, you're putting up only the end right over here. When you're putting 20, you're putting up the end right over here. That's it. Your start is fixed at 0 and your step is fixed at 1. So that is you are starting at 0 and each step is 1 unit. Okay, so I can write np.arrange. I want to start at 5. I want to go up till 161. The maximum was 160. Our maximum speed was 160. If I want to have 160 right over here, if I want to have 19 right over here, I will have to put 20 right over there. If I want to have 19 right over here, I will have to put 20 right over there. Okay, so for that I will be putting 160 plus 1. Are you guys able to understand this? The end will be 160 plus 1. That is the maximum plus 1. Okay, that will be 161 will be my end number. Up till where do I want to go? And then you are having the step. I want to take the steps in 5. Okay, 5, that should be, so you will be having an array, np array of 5, 10, 20, 30, sorry, 5, 10, 15, 20, 25, 30, 35 and so on and so forth up till 160. So this is the entire array that will be created for you. Not sorry, the 2R I've put it up by mistake. It's ARANGE. I'm so sorry, ARANGE. That was a spelling mistake from my end, guys. ARANGE. That is what we have studied. Okay, so it will create this entire NP array for us. So let's look at the code right now. So right over here, as you're able to see, we are having np.arrange. We want to start from 0. Okay, we want to go up till df speed.max. That will give us the maximum element from the column speed. Okay, that will give me the maximum element from the column speed. Although we know the answer, that is 160, but if we don't know, we can use df speed.max. That will give us the maximum element from that column plus 1, because we want to go up till that particular number. So we want to include 160 as well, and we want to take up the steps as 5. And now we can put it up in a particular, so this np.array is called as bins, and we can put it up inside our bins attribute as well. Okay, so I'm running this particular line of code. As you're able to see, we are having the bins array right over here. This is the bins array that we have been created, and we are incrementing it in 5 right over here. Along with that, each of the number of Pokemon that are having the speed in that particular range is being given right over here. It's ARANGE. We have studied this in NumPy, the same one. ARANGE. Okay, as you're able to see, ARANGE. We have studied this in NumPy. Okay, and this is the plot that we are able to get right over here. This is the plot that we have got. What is df speed? This is, see guys, we have already discussed this. This is the third time that I'm telling you guys. We're getting the column that is called as speed. df is this Pokemon data set right over here, and speed is the column from there. We want to get that column from there. Okay, so that is our speed, and dot max gives us the maximum speed in this column. It gives us the maximum value in this column right over there. Okay, so that is how we are able to plot our histogram. Okay. So this is something that you don't have to look at. Okay, this particular code is not for you guys. This is something that I was just explaining a way back. If you're not using, like if you're like overloading the entire plot with a lot many number of bins, okay, like 100, 50, 60 bins, then in that particular case, you're not able to get any type of value. You're not able to get any type of knowledge from this bin itself. Okay, so this is not something that you should be doing. Whenever you are taking up a histogram, it should always look like this. Okay, it should be connected to each other, and you should be able to see a pattern right over there. Okay, usually the right pattern is having 2 bell curves. Okay, you should be having 2 bell curves right over here. Like once it should go up, come down, again go up, come down. That is the type of curve that you are doing right over there. Okay. That is the type of curve that you are able to do right over there. Okay, are you guys able to understand this? This particular code you don't have to understand. This is something that I told previously as well. I'm just showing it out in code right now. Okay. Okay. Now an alternate approach. Up till now we were using your Matplotlib hist function to be able to plot our histogram. Okay, we can also use Seaborn to be able to do that. In Seaborn, we are having the dist plot that we have to use to plot the entire histogram. It is very easy. Like in your Matplotlib, you were able to see that there was so much that you had to write right over there. There's so much that you had to write right over there. Right over here, as you're able to see, you just have to write sb.distplot. Okay, and then you have to write the column that you have to use. So df.speed. Okay, you are using the speed column from our data set. Okay, if I'm running this particular line of code, immediately you are able to get the entire histogram plotted out very easily. Okay, you don't have to write all that code. It already plots everything out for you in a very easy to understand manner itself. Okay, and there's not a lot of coding involved. So that is why Seaborn does not have a lot of things that you can play around with, but it gives you a very simple format of the data visualization instantly. So that is why we use Seaborn. Okay. Now the dist plot has a built-in rules for specifying histogram bins. By default, plots a curve depicting the kernel density estimation on top of the dataset. Okay, the vertical axis based on the KDE rather than the histogram. You should expect the total height of the bar to be equal to 1. Okay, so right over here, as you're able to see, when you're creating this is the density that has been plotted for you guys. The total area under this curve would be 1. The total area under this curve would be 1. This is showing you the density. This line is basically showing you how the Pokemons are distributed along this entire speed. Okay, how this Pokemon is distributed along the entire speed. So basically, if you integrate the entire area under this curve, okay, and this is line, you will be able to get 1 as the answer. And this is the density that has been plotted. But I don't want to see the density. I want to see the histogram. I want to see how many like Pokemons are there for each of these speed. read. Okay, so for that you can just set KDE as false. Okay, you can just set KDE as false as an attribute, and you will be able to get the normal histogram that you are able to plot. Okay, you are able to get the normal histogram that you are able to plot. Okay, are you guys able to understand this? Please let me know, guys. Hist is basically histogram. Guys, able to understand this? Please let me know. Then remove the KDE by just writing KDE is false. Okay, great. Okay. Despite the fact that the default bin selection formula using by displot might be better than using 10 bins that the .hist uses, you might still want to do some tweaking. So if you want to still specify the bins according to what you want to do, okay, so for that, let us remove this first of all, that it's easier. We don't want to put it up right over here. Okay, so we can just put it up as bins as bin edges right over there, and that's the same as before as well, np.arrange function. If I'm running this particular line of code right over here, we are able to get this entire plot plotted out for us. Now the problem with this is that the color isn't very bright. Okay, the color isn't very bright, it's very dull right over here. We want to increase the contrast of the color itself. For that, we have another attribute that is present, hist kws alpha as 1, that basically increases the color contrast itself. Okay, this is basically to increase the color contrast. Hist kws alpha as 1. So I'm running this particular line of code. As you're able to see now, the same graph is having the color a bit more like bright and contrasted itself. Okay, so right over here, if I'm changing this to, let's say, 0.5, okay, so it will be a bit more like blurred out. As you will see, it's a bit more blurred out. So you can adjust the contrast according to you. It goes on to a value of 1. It goes on to the value of 1 where it is having the most contrast, and it goes down to a value of 0 where like it's the entire thing is like just vanished. You are not able to see anything. Okay. Are you guys able to understand this? Please let me know, guys. Naveed, I think so you are late for the class. I've already like given the exact answer to how like this entire thing functions. Okay, so for changing the color is the exact same. Okay, you just have to specify like the same thing that you were doing in your bar plots as well. Okay, so you don't have to do anything. You can just look at the bar plots and how to change the color. You will be able to change the color using the exact same thing. You don't have to do anything else. Okay, great. Okay, so alpha basically means the transparency that you want to set. So you are basically setting up the transparency right over there. Okay. Okay, so all the plots of the data visualization have been covered right over here. Tomorrow I will be uploading a video morning where you will be seeing the project, how to do the project, how to submit the project, where to submit the project, what will be the deadline for the submission of the project, when you will be getting the certificates. Everything will be discussed in that particular video. Okay, and there was no attendance for day 6, guys. Okay, there is no attendance for day 6. Okay, so you don't have to worry about it because the class, we were not able to take up the class, so there will be no attendance for day 6, guys. Okay. Okay, one more thing, guys, for those like many of you have enrolled into the program right now, we only have like 6 seats remaining in the program, so we had to create an entirely new batch for you guys as well. So if you are still interested in joining the data analyst training and internship program, or even the full stack web development training and internship program, you can contact me on this particular WhatsApp number that I have put up in the description itself. Okay, so you can contact me right over there and I will help you out with the entire process. Like I said, the entire training and internship program will be of 3 months. It will be continuous. If you are interested to learn, really like focus upon your placements, only then come up to the program. Okay, otherwise there's no need. Okay. Okay, so we'll look at that right over there as well. Thank you so much, guys, and yeah, EMI option is available in the program. We are able to understand that. That is the reason why we have the EMI option available. You can still enroll yourself today as well, because the classes have just started from today. If you still want, you can enroll in today's batch, or you can enroll for the 15th of July batch. Okay, for 15th of July, we have like 10 seats remaining up till now. If you want, you can definitely like enroll there as well. Okay, so I'll show you the attendance link for today, guys, as well. Give me a second. Day 7 it is. Those who want to enroll for the 15th of July batch as well, do that as soon as possible, because like I said, it's first come first basis. As soon as the number of seats are getting filled up, we will be like closing out the applications for that. So if you guys want to enroll in the program, definitely do that. Okay, there isn't anything that is there. Like I said, there is no attendance for day 6, guys. Okay, there's no attendance for day 6. You can scan this particular QR code, guys, and tomorrow morning we'll be having the project video. Okay. Okay. So thank you so much, guys. We'll meet tomorrow as well. Thank you. Thank you.